We'll start in about 5 minutes. Damon. Damon. Come on. Oh, hi. What's that? Bo Hackworth? Is that you?
Scott?
Yeah?
Yes, yeah.
Must be a challenge having a senior citizen as an instructor.
I was saying, I don't take any offense at that, I won't be those the amount of gray here, so. It's like the instructor yesterday was talking about his neighbor over the fence called Wilson. He goes, well, it's probably past most of your time because he was referring to that one with Tim Allen with his neighbor over the fence, Wilson. And I'm sitting there thinking about Wilson as Mr. Wilson from Dennis the Menace. So, yeah, he said, what, yeah. So he was talking about how feeding himself that way. And I don't think how many people even know about Dennis the Menace with Wilson. So, yeah, that was kind of interesting, talking about dating himself. But
Jose?
Nice Gerardo.
Hey, we'll start in a few seconds at 8 o'clock. Okay, it's 8 o'clock. We'll talk about solving absolute value inequalities today. So one of the keys to knowing how to solve an absolute value inequality is to first know how to solve an absolute value equation. Okay, we'll continue with the intro to solving absolute value inequalities. Let's just think about what we're looking at. So find the solutions to these basic absolute value inequalities. If the absolute value of x is greater than 3, x just represents a number. So if the distance from 0 that a number is greater than 3, then the number could be in a couple of different places. One part of the answer is all of the numbers to the right of 3 on the number line, because the distance that these numbers are from 0 is greater than 3. But there are other numbers, the numbers to the left of -3 on the number line. Also, all of these numbers have a distance from 0 greater than 3. Okay, so the algebraic notation for the solution set, we write x is less than -3 or x is greater than +3. This is the algebraic notation for the solution set. We're using the word or, that means union. We're combining all of the numbers in both sets for the solution set. The interval notation, well, the graph sort of reminds me of the interval notation. This part of the number line on the left, this is from -infinity to -3 parenthesis. And then we use the union symbol. And then this part of the number line, the numbers to the right of 3 are parenthesis 3, infinity. Okay, so it's important to understand that each of those two notations represent the same set of numbers. They're just two different notations. Algebraic notation on the left, interval notation on the right. Okay, the next example is pretty much like the previous one, except this time it's the absolute value of x is greater than or equal to 5. So think about what that means. So if x is a solution, then the distance that x is from 0 is greater than or equal to 5. So if we plot 5 and -5, one part of the solution are from 5, including 5, and to the right. So all of these numbers from 5 to infinity, they all have a distance from 0 greater than or equal to 5. But there's another part of the number line that is also part of the solution set. All of the numbers from -5 and to the left, all of those numbers have a distance from 0 greater than or equal to 5 also. So is this making sense? We're just thinking about what the definition of the absolute value is. The absolute value of a number is the distance that number is from 0. But we use positive numbers to measure distance. Okay, the algebraic notation. So this part of the number line to the from -5 and to the left. This is x less than or equal to -5. Then we use the word or. And this part of the number line from 5 to the right, this is x greater than or equal to 5. Okay, so this is the algebraic notation for the solution set. And then the interval notation. So on the left, we have parenthesis -infinity, comma, -5, bracket. And then the union symbol. So the union symbol in interval notation corresponds to the word or in algebraic notation. And then the other part of the solution, we have bracket 5, comma, infinity. Okay, let's look at the next example. The absolute value of x is greater than -2. So can you think of any numbers whose distance from 0 is greater than -2? Okay, +2, that's a solution. The distance 2 is from 0 is 2, and 2 is greater than -2. Is that the only number? It's the only number? Okay, what if I pick -10? And for x, if I pick x to be -10, so we're just experimenting. We're trying to figure out what the solution is. So I'll just write this down as an experiment. So don't be afraid to try experiments. That will lead to more knowledge. So I'm going to pick x to be -10. And then in this inequality, I'm going to replace x with -10. So I get the absolute value of -10 greater than -2. Is this true or false? True or false? Right, we're just doing an experiment. What's the absolute value of -10?
That's a no
10.
solution.
10. The absolute value of -10 is 10. 10 greater than -2. True or false? It's true. So -10 is a solution. Okay, we picked two numbers and they were both solutions. Can you think of a number that is not a solution? That could be another experiment. Think of a number that you think might not be a solution.
-1.
-1? Okay. So experiment part 2, this time pick x to be -1. And then in the inequality, replace x with -1. The absolute value of -1 greater than -2, question mark. We want to know if this is true or false. What's the absolute value of -1? 1. 1 greater than -2, true or false? It's true. Right? 1 greater than -2. 1 is greater than -2.
We have positive.
Positive one?
Absolute value of +1.
Positive 1? So if we replace x with +1, we're still going to get 1 greater than -2 because the absolute value of 1 is 1. So 1 is also a solution. So far, we haven't found any numbers that are not solutions. We've only picked numbers that turned out to be solutions. Okay, think of it this way. Remember yesterday, I wrote, on paper, there was the statement, the absolute value of a number is never negative. The smallest number that the absolute value could be is 0. But other than that, the absolute values are positive. Right? So the smallest that the absolute value of x could be is 0. Is 0 greater than -2? Yes, 0 is greater than -2. And then any other real number has an absolute value that's positive. And a positive number is always greater than a negative number. So what's the solution set? All real numbers. Every real number is a solution because the absolute value of any real number is either 0 or positive, right? And 0 is greater than -2, and a positive number is greater than -2. So this inequality, the solution set is all real numbers. So we'll just say all real numbers are solutions, all real numbers. All real numbers are solutions. What's the interval notation for all real numbers? Yeah, -infinity to positive infinity, surrounded by parentheses. So parenthesis, -infinity, comma, infinity. That's the interval notation for all real numbers. Okay, ponder that. If it still doesn't quite make sense, think about what we were just discussing. The absolute value of a real number is always greater than a negative number, always. Okay, the next one, this time we have the absolute value of x is less than 4. So where on the number line are the numbers whose distance from 0 is less than 4? Well, we'll draw the number line and put 0 there. So where are the numbers whose distance from 0 is less than 4? Okay, I'll plot the number 4 to start with. So on my graph so far, can you see where some of the numbers are whose distance from 0 is less than 4? So where are they?
0 and 3.
Yeah, we know that these numbers between 0 and 4, and we exclude 4, these numbers right here have a distance from 0 less than 4. But there are also some negative numbers whose distance from 0 is less than 4. So the numbers that are between -4 and 0, those also have a distance from 0 less than 4. So this is the graph of the solution set. The distance from 0 for all of those numbers is less than 4. So those numbers cannot break out to the right. They can't break out to the left. They can only be so far away, right? Because the distance is less than 4. It's like the numbers are on a tether. They can't get very far away, right? It's limited in 2 directions. You see that? Okay, so what's the algebraic notation So think of x as a number that's in this interval. It's between -4 and 4, but we exclude the endpoints. We can get as close as we want to those endpoints from the inside, but we never actually get to the endpoint.
I am confused on a point here.
So the algebraic notation, it's a compound inequality. What's the matter?
-4 is if you, the real number can never be a negative. That's what right now my confusion is. Could -4 be?
I can't really understand what you're saying.
Oh, I'm sorry. Negative, that a real number cannot be a negative. And so how could -4 be part of the solution for x, because it's a real number? That x is supposed to be a real number. How can a negative number be a real? Because that's where I'm at is, how can a real number be a negative when the real number is not supposed to be a negative? And that's where my confusion is.
Getting what you're
So, the real number, which is in the bracket.
X represents a real number.
Yes, which is, can only be positive, and you're saying that -4 can be part of the solution.
Yeah, but -4 is excluded from the set
Oh, okay,
because it's not,
Okay.
it doesn't have the or equal to part.
all right,
That's why we're using a parenthesis to indicate that the endpoints are not included.
oh, all right,
If it were less than or equal to 4, then we would use a bracket because the endpoints would be included in that case.
oh, okay, got it.
Did-
But
did that
it's a
clear
little,
up?
it's a little clearer.
Yeah, so there was a question about including -4 or excluding -4. The parenthesis at -4 indicates that -4 is not part of the solution because 4 is not less than itself, so we exclude the endpoints. Okay, so the algebraic notation, if x is in this interval, then we can write -4 is less than x, and at the same time, x is less than +4. So this is two inequalities combined by the word and. We covered this a couple of days ago. But when the word and is used, we don't write the word and, we just write, in algebraic notation, we write -4 is less than x, which is less than 4. If you read this, you can say the word and, -4 is less than x, and x is less than 4. So remember what and means. It means that a number satisfies two conditions at the same time. So one of the conditions is that -4 is less than x. And at the same time, the other condition is that x is less than 4. And this resembles, in a way, it resembles the graph of the solution set. Just think of x being a number in this interval. Okay, the interval notation. So this set of numbers, since we're excluding the endpoints, we use a parenthesis, -4, comma, 4 parenthesis. The parentheses on the ends indicate that they are not part of the set. Okay, the next one is similar to this one that we just finished. This time, though, it's the absolute value of x is less than or equal to 6. So we want to know all of the numbers whose distance from 0 is less than or equal to 6. So the numbers that are between -6 and 6, including -6 and 6, are solutions. Yeah, if the distance a number is from 0 is less than or equal to 6, it means that the number is on a rope. It can't get very far away. It can't break out to the right of 6, and it cannot break out to the left of -6. It has to stay within 6 units of 0. See how that works? Okay, so the algebraic notation, if x is in that interval, then we can write -6 is less than or equal to x, which is less than or equal to +6. So once again, I'll just mention that this compound inequality, -6 less than or equal to x less than or equal to 6, it's two inequalities combined by the word, or combined with the word and. So one way to read this is -6 is less than or equal to x and x is less than or equal to 6. Since we use the word and, both conditions have to be satisfied. Okay, then the interval notation, this time we use bracket -6, comma 6 bracket. The bracket corresponds to the or equal to part in the inequality, in the algebraic inequality. Okay, let's look at the next example. The absolute value of x is less than -3. Remember that the absolute value of a real number is always, well, it's never negative. The absolute value of 0 is 0, but then for any other number that's not 0, the absolute value of a real number is positive, a positive number. So you can test all of the possibilities. We only have to consider two cases. If x is 0, what's the absolute value of 0? 0. Is 0 less than -3? No. So 0 is not a solution. Then if you pick any other real number besides 0, the absolute value is a positive number. Is a positive number less than -3? No. A positive number is never less than a negative number. So that means this inequality has no solution. There are no numbers whose distance from 0 is less than -3. Does this make sense? So no solution. When there's no solution, we use the empty set, the set that has no elements or no members. Okay, so I'm thinking that if you just think about what you're looking at and apply the definition of the absolute value, you can figure out how to solve the absolute value inequalities. You can always go back to these basic examples that we looked at to help you solve more complicated absolute value inequalities. Okay, so let's look at some more complicated ones. Okay, in the when we were solving absolute value equations yesterday, the first thing we wanted to do was get the absolute value part by itself. And we also want to do that with absolute value inequalities. So this one, to get the absolute value of 2x minus 1 by itself, we first have to subtract 4 from both sides. So we'll get the absolute value of 2x minus 1 is less than or equal to positive 2. Okay, so we're looking at a situation that we've already encountered in the more basic examples. So just think of 2x minus 1 as a number. We do want to solve for x, but just think of 2x minus 1 as a singular number. If the absolute value of a number is less than or equal to 2, then where is that number on the number line? If the distance from 0 is less than or equal to 2,
between positive 2 and negative 2.
Yeah, then that number has to be between negative 2 and positive 2. That make sense? So just think of 2x minus 1 as a number because that's what it represents. If its distance from 0 is less than or equal to 2, then we can remove the absolute value symbols and we can write negative 2 is less than or equal to 2x minus 1. And at the same time, 2x minus 1 is less than or equal to 2. So do you agree the numbers that have the form 2x minus 1 are in the interval between negative 2 and 2? Because if the absolute value of 2x minus 1 is less than or equal to 2, then 2x minus 1 has to be between negative 2 and 2, including the endpoints. Does that make sense? This is just a little bit more complicated than the corresponding basic example that we did a few minutes ago. Okay, the goal is to solve for x. So to get x by itself in the middle, we're just going to do the same thing to all three parts of this inequality. The first thing we'll do is we'll add 1 to all three parts. As long as we add the same number to all three parts, the inequality will remain true. So since we want to solve for x, and we're starting out with 2x minus 1, we want to add 1. So we'll add 1 to all three parts. Negative 2 plus 1 is less than or equal to 2x minus 1 plus 1, which is less than or equal to 2 plus 1. And then we'll simplify a little bit. Negative 2 plus 1 is negative 1, less than or equal to 2x minus 1 plus 1 is just 2x. And that's less than or equal to 2 plus 1, or 3. Okay, now we're ready for the next step. We want to solve for x. So what should I do to all three parts this time? Yeah, divide each of the three parts by 2. So negative 1 divided by 2 is negative 1/2, less than or equal to 2x divided by 2 is x, which is less than or equal to 3 divided by 2 is 3/2. Okay, and we're done. We have the algebraic notation. This is the algebraic notation. And what's the interval notation? So x has to be between negative 1/2 and 3/2, and it could also be one or the other of the endpoints. So the interval notation is bracket negative 1/2 comma 3/2 bracket. This is the interval notation for the same set of numbers. Okay, the next example, this time we have the absolute value of 3m minus 6 is greater than or equal to 9. So think about what that means. 3m minus 6 just represents a number. So where on the number line are the numbers whose absolute value is greater than or equal to 9? Yeah, to the right of 9, let's see, to the right of 9 or 9, and to the left of negative 9. So these numbers cannot get close to 0, very close, right? If the distance those numbers are from 0 are greater than or equal to 9, they have to stay a minimum distance from 0. So with that in mind, if we just sketch a graph, I'll plot 0, negative 9, positive 9. So the numbers that have the form 3m minus 6, if their distances from 0 are greater than or equal to 9, well, those numbers are either to the right of 9, including 9, or they are to the left of negative 9, including negative 9. Okay, so this is a rough sketch of the graph, but this just represents 3m minus 6. Okay, so let's write down algebraically what this means. So numbers that have the form 3m minus 6. Well, they could be in two different places this time. So 3m minus 6 could be less than or equal to negative 9. 3m minus 6 could be less than or equal to negative 9. Then what should I write? The word or. See, there are two different parts of the number line where the distances are greater than or equal to 9. So a number of the form 3m minus 6 can only be in one of those places at once. So either 3m minus 6 is in this interval on the left, or the number is in the interval on the right. We use the word or because it cannot be in both places at the same time. So using our graph to help us, 3m minus 6 is either less than or equal to negative 9, or 3m minus 6 is greater than or equal to positive 9. Is this making sense? We want to solve for m, so in each of those two inequalities, we'll just solve for m. We learned how to solve inequalities a couple of days ago. So if 3m minus 6 is less than or equal to negative 9, first add 6 to both sides, and we get 3m is less than or equal to negative 3, because negative 9 plus 6 is negative 3. And then let's go ahead and finish it. If 3m is less than or equal to negative 3, divide both sides by 3, we get m is less than or equal to negative 1. And then we're using the word or. We'll solve the other inequality. If 3m minus 6 is greater than or equal to 9, we add 6 to both sides. So we get 3m is greater than or equal to 15. And then divide both sides by 3, we get m is greater than or equal to 5. Hey, this is the algebraic notation. So when the word or is involved, the algebraic notation uses the word or. So this is the algebraic notation. Okay, what's the interval notation? We've had some practice with that also. So you can use this was the original graph before we solved it for m. The graph for the solution m, well, if m is less than or equal to -1, and m is greater than or equal to 5, then the graph has a bracket at -1 and shade to the left. The other part is a bracket at 5 and shade to the right. So this is the graph of the solution for m, right? So the interval notation, so this part of the number line from -infinity up to -1, including -1, we write parenthesis -infinity, comma, -1, bracket. And then we use the union symbol. And then the other part of the number line is bracket 5, comma, infinity. This is the interval notation. This third example is similar to the very first one that we did. It's just that this time we have less than instead of less than or equal. Okay, but this one's all set up for us. That is, the absolute value is by itself on one side. So I'll explain it's the same method, just worded a little bit differently. If you have the absolute value of an algebraic expression is less than a positive number, what we can do is we can first solve an absolute value equation. First solve the absolute value equation we get when we replace the inequality with equals. Okay, so you need to know how to solve an absolute value equation. If the absolute value of 3y plus 2 is equal to 8, then there are two possible solutions for 3y plus 2. When you remove the absolute values, one possible solution involves 3y plus 2 equals positive 8. The other one is 3y plus 2 equals negative 8. Right? If the absolute value of a number is 8, then that number could be 8, or that number could be negative 8. Okay, then we'll solve each of those equations. If 3y plus 2 is 8, subtract 2, 3y is equal to 6, and then divide by 3, y is equal to 2. Solve the other equation for y, subtract 2 from both sides, we get 3y equals negative 10, and y equals negative 10 thirds. Okay, with those two numbers, 2 and negative 10 thirds, we plot them on the number line. So negative 10/3 is to the left of positive 2. And those two numbers divide the number line into 3 separate intervals. Now I'll label the intervals 1 on the left, 2 in the middle, and 3 on the right. So this is the test point method. We pick a test point from each of the 3 intervals to represent y, and then in the original inequality, we replace y with the test point, and then we determine if the resulting inequality is true or false. Okay, so we're going to pick test points in this method. So in the first interval, pick any number that you want that's less than negative 10/3. Negative 10/3 is negative 3 1/3, so a convenient number that's smaller than that is negative 4. You can pick any number you want, but I'm going to pick x to be negative 4. And then in the inequality, the absolute value of 3y plus 2 is less than 8. I'm going to replace y with negative 4. So I'm going to get the absolute value of 3 times negative 4 plus 2 less than 8. Let's do a little bit more arithmetic all at once. Inside the absolute value, 3 times negative 4 is negative 12. Negative 12 plus 2 is negative 10. So we get the absolute value of negative 10 less than 8. The absolute value of negative 10 is 10. 10 is less than 8. So is that true or false? Okay, that's false. Okay, so that means the number we picked is in the first interval. So that means since the number we picked from the first interval led to a false inequality, we conclude that no other number in that interval is a solution. So none of the solutions are in the interval from negative infinity to negative 10/3. Okay, the middle interval, negative 10/3, the numbers between negative 10/3 and 2, we can pick any number we want in the second interval. 0 is in that second interval, and 0 is a convenient number to pick. Oh, when I wrote x, I shouldn't have written x or variable as y. Sorry about that. Okay, so in the second interval, let's pick y to be 0. And so in the inequality, we get the absolute value of 3 times 0 plus 2 is less than 8. 3 times 0 is 0. 0 plus 2 is 2. So we get the absolute value of 2 is less than 8. The absolute value of 2 is 2. 2 less than 8. Is that true or false? Okay, that's true. So that means the interval from which the test point came is part of the solution set. So yes, all of the numbers between negative 10/3 and 2 are solutions. Okay, we can do the third interval really quick. If I pick y to be 3, that's greater than 2. And let's do this in our head. If we replace y with 3 inside the absolute value, 3 times 3 is 9, 9 plus 2 is 11. The absolute value of 11 is 11, and 11 less than 8 is false. So that means none of the numbers in that third interval are solutions. Since the inequality that we started out with does not have the or equal to part, then that means we exclude the endpoints. So I've encroached on a different problem here, but I'm going to use its space. So graphically, our solution set are the numbers that are between negative 10/3 and 2. So graphically, we put a parenthesis at the endpoints to indicate that the endpoints are excluded. This is the graph of the solution set. This is the second interval that we tested. And so the algebraic notation, we write negative 10/3 is less than y, which is less than 2. The interval notation is parenthesis negative 10/3, comma 2, parenthesis. Okay, I want to write the same inequality that we just solved using that method. Okay, this is the same inequality that we just solved using the test point method. And the test point method is a perfectly fine method, but I think it's probably more efficient if you just think about what this is telling us. If the absolute value of a number that has the form 3y plus 2 is less than 8, then the distance 3y plus 2 is from 0 is less than 8. So the numbers that have the form 3y plus 2, they have to be between negative 8 and 8. So in other words, negative 8 has to be less than 3y plus 2, which is less than 8. Isn't that right? If the distance this number is from 0 is less than 8, it can't get farther than 8 units away, right? So we can just solve this directly. I'll rewrite this. This will be our last task for the day. If negative 8 is less than 3y plus 2, which is less than 8, we can solve this compound inequality for y if we do the same thing to all three parts. First, subtract 2 from all three parts. Negative 8 minus 2 is negative 10. In the middle, 3y plus 2 minus 2 is 3y. And on the right, 8 minus 2 is 6. And then lastly, divide each of the three parts by 3. Negative 10 divided by 3 is less than 3y divided by 3, which is y, is less than 6 divided by 3, which is 2. We get the same result. Negative 10/3 is less than y, which is less than 2. This is the algebraic notation. And the interval notation, parenthesis, negative 10/3, comma 2, parenthesis. This is exactly the same answer we got using the other method called the test point method. Okay, it's time to quit. So if you came in and I didn't get your attendance, make sure you check in with me. Brianna. Damon's here, right? That's you. Austin Cook. Ida Dane. Jose Sevilla. Mrs. Fountain, Brianna Garcia. Scott Holden.
Okay.
That's you. Marcos Holden. Oh, that's you. Richard Reynolds. Gerardo Holden. That's you. Taylor Williams.